an instructor wishes to catalog the different teaching styles of PCC instructors, the instructor cannot visit every class, so instead she will gather a random sample. Now, however, just to clarify something, if she did visit every class, then if this would be considered a census, meaning if we sample the whole population, then that is a census. Okay, so that's what a census is, when you sample everything. All right, so let's look at this first one here. The instructor separates the courses by discipline. Okay, so we're separating everything by discipline here. From each discipline, the instructor randomly selects 3 classes to visit. Okay, so what do we know about the disciplines? Well, you know, we think of disciplines as being unique, right? So maybe the style of teaching for one discipline varies considerably from another. So if that's the case, the disciplines become the strata. A particular style that, if you were, really doesn't apply to the whole population. So this is a stratified random sample. Okay, the instructor lists out all the classes offered that term and enumerates each class, numbers them. Then from the created list, the instructor randomly selects 50 classes to visit. Okay, so in this case, every class has an equally likely chance of being chosen. Okay, so in this case, this is going to be a simple random sample. Notice in this first one, we separate everything by discipline, so which is stratified. I believe that's not the way you spell it, stratified. Or am I just get confused about that? Yeah, I don't know why I write stratified that way. Okay. So, but in this case, we don't. We just leave them as is. We enumerate everything, and then just select 50 classes to complete a random. We're using a random number generator. So again, this is a simple random sample. Every class is equally likely to be chosen. In this case, every class is not equally likely to be chosen, because if we separate everything by discipline, you know, once we separate, in this case, we're going to do 3 classes to visit. So once we visit the 3 classes, the other classes in that discipline don't get a chance to be chosen. But in this case, number 2, it is possible that every class is from the same discipline. Not likely to happen, but could. All right, the instructor, number 3 here. The instructor randomly selects a campus. From that campus, the instructor randomly selects 50 classes to visit. Okay, so how do we think of campuses? Do we think of them as unique, or do we think of them as, you know, one campus is the same as another campus? So this one's a bit tough because you have to kind of figure it out. And I'm not sure if I even myself have the answer to this question. But I'll say this. If we assume that each campus is representative of all the PCC campuses, then this is a cluster. Couldn't think of the word for there. Okay, but again, it's making this assumption about the makeup of a campus. Each campus represents any other campus, so this would be a cluster, because a cluster is a mini representation of the entire system. All right, let's look at this next one here. The instructor sends out an email to all instructors teaching at the college asking if she can visit their classroom. The instructor will visit the first 50 people that respond. So this is called a volunteer, because the instructor is not choosing the classes via, I guess, a randomized process. The instructors or the classes are being self-selected. Okay. So again, this is a volunteer sample, and again, volunteer samples are not going to produce representative samples. So this is really not a good method. Okay, so volunteer samples are not a good method to sample. The courses PC are enumerated by CRN numbers. Okay, great. The instructor will choose the first CRN at random, then next choose 150, the next CRN 150 away from the first one, and so on until 50 classes have been chosen. Now, this is going to be a systematic. Okay, so the idea of a systematic is, again, somehow the population, the objects of the population have to be enumerated in some way, or there's got to be some order in order to do this. So once there's some type of order, we can choose randomly the starting point. And then once you find that starting point, choose a predetermined amount away. In this case, it was 150, but choose some predetermined distance away from that first one and keep going until you have reached your desired sample size. Okay, so this one's systematic. So why do we random sample from a population? What is the purpose? What will go wrong if we did not do this random sample? So let me do this. I call this 1, 2, 3. 3 questions here. So let's look at the first one. So we do this. We randomly sample to create a representative sample. Yeah. Meaning the sample is a good representation of the population. All right. 2, what is the purpose? So the idea here is that once we get a sample, we're going to measure things and then summarize things from the sample. So the summaries, which are really the statistics from each representative sample, will have a good chance of being a good estimate of our population, of our parameters, whatever they happen to be. I was going to say population parameters, but that's kind of overkill. A parameter is from a population. So that's really the reason. What about number 3? What will go wrong if we do not randomly sample? So back to the statistic. So the statistic generated from our sample will have a high probability of not being a good estimate of the parameter. Okay, so if it's not representative, then again, we're not going to get a good estimate, and that's the purpose behind it. I'm going to ask one more thing. And so if our sampling method is no good, then our statistics in the long run will not produce good estimates. So we say the sampling process, is biased if it is systematically producing, not representative samples. So you have a bad sampling method, but then each time you use it, well, there's a good chance it's not going to be reproduced. So then we say that, again, the sampling process is biased. All right, here's the last thing here. Consider just a national poll, such as the presidential approval rating. Okay, what is the number of adults in the American population? A rough estimate. So I sort of looked it up, and the U.S. population, adult population, I mean, this is very rough, is about 258 million adults. Okay, so that's it. How many Americans do you think are polled for presidential approval ratings? Like, for example, how is the president doing? And again, you'll be surprised. The answer is around 1,200 to 1,500, somewhere in there. Maybe a little lower, maybe a little larger, but it's around that number typically. Okay, and that's it. So that's all that are polled typically for a presidential approval rating. So we see this in the news. How is President so and so doing? That's about all they've polled. So the question becomes, well, how is that possible? The population is about 250 million. How come 1,200, 1,500 represent that? So here's a couple things just to keep in mind. So the one truth you want to keep in mind is that the sample size used in any study is not, can't repeat this, it's not dependent on population size. Okay. Suppose we ask the same question for Oregonians. How's the president doing? We would sample the same amount, 1,200 to 1,500. So why wouldn't we sample less? The answer is no. What we want is to be, if we sample Oregonians, then we want to know the opinion of Oregonians. If we sample the United States, then we want to know the approval rating for the United States. But the number, what this number is trying to do is limit the variability. So the sample size limits the variability of our statistics. Okay, so we need to pick the right sample that's going to limit the variability of our statistics. So really, what is a sample size dependent on? Sample size is dependent on the variability of our measurement. Okay, so if we were measuring cholesterol levels, then what we care about is, well, how far, for example, if we care about cholesterol, what we need to know is the variability of cholesterol level. That will determine the sample size. So it has nothing to do with a large population or a small population, but it has to do with the variability. How much does our data vary? And that will determine the sample size. Okay. Anyway, one last thing here about this. So for example, if say 45% approve how the president is doing, then really what we have found, the symbol used to represent this is p hat, the sample proportion. Okay, so we would write this, I'm going to write it here roughly. So p hat will be equal to what this is trying to estimate is p, which we don't know. which is the actual proportion that approve how the president is doing.